A liquid silicate blanket wrapped around the core of Mars gives us new clues about the planet's history and why it is devoid of life, researchers have said. Findings from a paper published today in the journal Nature provide insights into how Mars formed, evolved, and became the barren planet it is now, according to an international team of researchers. NASA's InSight mission to Mars launched in 2018 and has helped scientists map out the planet's internal structure, including the size and composition of its core, and provided general hints about its tumultuous formation. The mission officially ended in December 2022, after more than 4 years of collecting Mars data, but analysis of its observations continues. The findings published today, which cast doubts on the first estimates of the red planet, are from the analysis of a powerful meteorite impact observed by the InSight mission that occurred in September 2021. Image an undated NASA image of Mars. The journal details the use of seismic data to locate and identify a thin layer of molten silicates, rock-forming minerals that make up the crust and mantle of Mars and Earth, lying between the Martian mantle and core. With the discovery of this molten layer, the researchers determined that Mars' core is both denser and smaller than previous estimates, a conclusion that better aligns with other geophysical data and analysis of Martian meteorites. Molten layer is like a heating blanket. Vedran Lekic, a professor of geology at the University of Maryland and co-author of the paper, compared the molten layer to a heating blanket covering the Martian core. The blanket not only insulates the heat coming from the core and prevents the core from cooling, but also concentrates radioactive elements whose decay generates heat, he said. And when that happens, the core is likely to be unable to produce the convective motions that would create a magnetic field, which can explain why Mars currently doesn't have an active magnetic field around it. Why is there no life on Mars? Without that functional protective magnetic field around itself, a terrestrial planet such as Mars would be extremely vulnerable to harsh solar winds and lose all the water on its surface, making it incapable of sustaining life, Professor Lekic said. He added that the difference between Earth and Mars' internal structures could explain why there is life on one and not the other. The paper's lead author, Henri Samuel, a scientist with the French National Centre for Scientific Research, said the thermal blanketing of Mars' metallic core by the liquid layer at the base of the mantle implies that external sources are necessary to generate the magnetic field recorded in the Martian crust during the first 500 to 800 million years of its evolution. These sources could be energetic impacts or core motion generated by gravitational interactions with ancient satellites, which have since then disappeared, paving the way for future missions. The team said their conclusions support theories that Mars was at one time a molten ocean of magma that later crystallized to produce a layer of silicate melt enriched in iron and radioactive elements at the base of the Martian mantle. The heat emanating from the radioactive elements would then have dramatically altered the thermal evolution and cooling history of the red planet, according to the paper. These layers, if widespread, can have pretty big consequences for the rest of the planet, Professor Lekic said. Their existence can help tell us whether magnetic fields can be generated and maintained, how planets cool over time, and also how the dynamics of their interiors change over time. This new discovery of a molten layer is just one example of how we continue to learn new things from the completed InSight mission. We hope that the information we've gathered on planetary evolution using seismic data is paving the way for future missions to celestial bodies like the Moon and other planets like Venus.